All right, so in this section here, we're doing section 11.4. It's actually one of my favorite sections. And the section is all about angles and how they are related to arcs on a circle. One thing you might want to have in your hand is if you're taking notes along with, you might want to have 4 different color pens to start. And you'll see hopefully as we get to the bottom of the page, on the first page of notes, you'll hopefully see why. Okay, so let's start out real basic here, and we'll start out with a central angle. So that's the type of angle we're talking about. And a central angle has its vertex at the center of the circle, and the measure of the angle is the same as the measure of the intercepted arc. So when we're talking about an intercepted arc, I like to think about it's almost like this is a Pac-Man. So you got a Pac-Man here. Hopefully you can all kind of see the Pac-Man. Hopefully you all know what Pac-Man is, and how it eats this arc right there. So that is the intercepted arc, the blue arc that the Pac-Man is eating. And so if I have an example here, if this angle here is 40, then I know that the measure of this arc is 40. Or likewise, if I know the measure of the arc is 40, then the measure of the central angle is 40 degrees. Okay. Next type of angle is what's called an inscribed angle. And an inscribed angle has its vertex on the circle. And an inscribed angle has a measure that is half of the intercepted arc, or half of the the arc that the Pac-Man is eating. So in this case, it's that arc right there. So hopefully y'all can see the mouth eating that particular arc. And so if I take a look at an intercepted arc like this, where this is, say, 70 degrees, I know that this angle here is half of that. It's 35 degrees. The next type of angle is called a tangent chord. So you have a tangent and then a chord of a circle, and its vertex right there is also on the circle, and it also is half of the intercepted arc. So the arc that it intercepts, or the arc that it's eating, is this arc right there. So if I have a tangent chord angle, and this arc right here was, say, 100 degrees, then this angle here would be 50 degrees. It would be half of that. The next type of angle is, we'll do a chord angle. So chord and then a chord. And the angle that we're talking about getting is these two angles here. Hopefully you can see that they're the same because they're vertical angles. And the intercepted arcs, or the arcs that it's eating, those two angles, would be this one and that one right there. And it's going to be, the vertex is inside the circle, and it's going to be half of the sum of those intercepted arcs. So if I have a chord, let me draw the chord in here, and this angle is 40, and this one is, say, 20, then I know it's going to be 40 plus 20 divided by 2, or 30 degrees. So that would be that angle right there, as well as the vertical angle across from it. Let's see. The next one is going to be a secant. A secant intercepts secant intercepts or cuts through, intersects the circle in two different places. And the vertex of this is outside of the circle. Okay, so that's going to be the vertex right there. And it's going to be half of the difference of the intercepted arcs. And hopefully you can see that. I'm going to use a different color here. This and this arc are the two arcs that it intercepts. And so in this case, it's like this. And if I know that this is, say, 90 and this is 40, it's going to be 90 minus 40. You always want to take the bigger arc first, divided by 2, half of the difference of those intercepted arcs. And that's just going to be 25. And so that angle right there is 25. Okay, next one is going to be what we call a secant tangent. That's a tangent, that's a secant. So we're looking at this angle right there. Again, it's outside of the circle. And the intercepted arcs are going to be the arcs that this mouth is eating, this one and that one. And again, we're looking at half the difference of those intercepted arcs. And so if I go like this and like this, let's say make this 100 and make this, say, 60, then I know it's going to be 100 minus 60 divided by 2, or it's going to be 20 degrees, and so that angle right there will be 20 degrees. And the last one is going to be a tangent. So looks like a snow cone almost. And again, the angle is on the outside of the circle. That's the angle right there. And the intercepted arcs will be right here and right here. And once again, we're looking at when it's outside of the circle, it's going to be half the difference. So if we have a tangent, and I know that this is, say, 220 degrees, which makes this going to be 140 degrees, right? Because I have to add up to 360. It's going to be 220 minus 140. Oops. 140 divided by 2, which gives me 80 divided by 2. And that's going to be 40. And so that's going to be that angle right there. Okay, so the names of these angles are not important. However, what I'm going to show you here, if I just pan out a little bit, the location of the vertex is really what you need to be focused on here. So if you look at this first one here, I meant to do this all in black, but this is what happens when you are at the center. When the vertex is at the center, this is what happens when the vertex is on the circle. This is what happens when the vertex is inside the circle. And this is when the vertex is on the outside of the circle. There's 4 things you need to remember here. So if you look at this, when the vertex is at the center, the measure of the angle is the same as the measure of the intercepted arc, or what the Pac-Man is eating there. When it's on the circle, it's going to be half of the arc that it's eating. When it's inside the circle, it's going to be half the sum. And when it's outside of the circle, the vertex is outside of the circle, it's going to be half the difference. So we'll go ahead and try some of the problems on the next page. Okay, I know there was a lot of information on that front page there, but hopefully you'll see that it's not quite as bad as it looks on the front page. As I mentioned earlier, there's 4 different things here you want to remember. When it's at the center, it's the same. When the vertex is on the circle, it's going to be half. When it's inside the circle, it's going to be half the sum. And when the vertex is outside the circle, it's going to be half the difference. Okay, so let's take a look at this. I look at this first problem here, A, and I see that the vertex is on the circle. So I know it's going to be half of the intercepted arc, and that the intercepted arc is this guy right there. So I need to find that intercepted arc. I know that this side of it is 220. So I know that this must be 140 degrees, because that together they have to add up to 360 degrees. So the arc, intercepted arc that the Pac-Man's eating is 140. That makes this half of it, or 70 degrees. So this is just going to be 70 degrees. All right, this angle right here is the one we're looking for next. It's going to be outside the circle, and so now we're looking at the intercepted arcs being here and here. And we know that when the vertex is outside of the circle, it's going to be half of the difference between the intercepted arcs. So it's going to be 160 minus 50 divided by 2, because it's half. And so it's going to be 110 divided by 2, or it's going to be 55 degrees. The next one here is going to be the vertex we're looking for. It's actually this one, but I know I can find this one right here first. Oh, look like a little smiley face there. I know that these are the intercepted arcs for the 2 dotted angles here and here. So I know that I can find these 2 angles right there. It's going to be half of the sum, so it's going to be 120 plus 80 divided by 2. So it's going to be 200 divided by 2, or 100 degrees. That's going to be that measure of that angle right there, but I know that this is supplementary to it, so it's 80 degrees, and that is going to be that angle right there. All right, the next one. I'm looking for this angle here, which is outside the circle. Again, when it's outside the circle, I'm looking at half the difference. So I'm looking at this one, and this are the intercepted arcs. I don't have this arc right here, but I do know that this is 120 and this is 10. So that's 130. And I know that together this is a semicircle here. So this must be 180 minus 130, or 50. So I know it's going to be 50 minus 10 divided by 2. It's half the difference. So it's going to be 20 degrees. All right, the next one here, I'm looking for arc CD. This is the one I'm looking for right there. And I see that I'm given this arc this angle that is on the vertex is on the circle. So I know it's half of the intercepted arc, which is this arc right here. I know it's half of this arc right there. So I know that this must be 150 degrees. I also know that these 2 chords are congruent to each other, which means that this has to be 150 also. The corresponding arcs are going to be congruent to each other. These are both 150, 300 together. That makes this 60 degrees, and that's the answer. Okay, and the last one right here is I'm looking for arc AB. And I'm given this guy, and I'm given this one. I know that this angle over here is outside the circle. It's going to be half of the difference between this arc and this arc. And so I know, and this is a little bit tougher, but I could just plug it into an equation. Let's call this x. So it's going to be x minus 75 right, divided by 2, half the difference of the yellow intercepted arcs is equal to this guy right here, 50 degrees. 50 degrees right there. And so then I know that x is going to end up, if I solve this, multiply both sides by 2, add 75 to both sides, x is going to be equal to 175 degrees. That's this arc right there. And then I know that if I subtract from 360, I know that this is going to end up being 110 degrees. Okay, that last one was kind of tough, but most of the other ones weren't hopefully too bad. And I'm going to go ahead and stop here and give you an opportunity to try some of the problems from the book. All right, take care.